Okay, guys, we're going to go ahead and start your semester review. This is everything that you need to know for your final that you'll be taking this week. Now, to start off, we see that we have basic research, applied research, technological development. Basic definitions of these: basic research is done to increase the knowledge, applied research is done to solve a problem, and technological development is done to improve the quality of life. Technology, its basic definition is the application of knowledge for practical purposes. So what we see is basic research is done just to increase the knowledge on the subject matter. Applied research is done that we want to solve a problem, and technological development is just the application of applied research in something that improves the quality of life. Now, the types of properties that we talked about earlier in the semester, we talked about physical changes and we talked about chemical changes. Now, the physical changes basically is just the characteristics that can be observed or measured without changing the identity of the substance. And the main thing here is without changing. Guys, the main thing about anything physical changes or physical properties, um, we never change what the substance is. When we're looking at ice and thinking about water, if we take an ice cube and melt it, it's still the same. It's still water. It's still H2O. It's just in a different state. So that'd be like an example of physical change. Now, a chemical change, it relates to the substance's ability to undergo changes that transform it into a different substance. Basically, what we say here is that anything chemical change, chemical reaction, we see that it changes into something different. It transforms into something completely different. We cannot get it back to what it was. We can look at examples of that. We're talking about rusting or combustion, tarnishing, hardening of cement. We see that it changes into something different and we can't get it back to its original state. Now, some important SI base units that we have here. We have length, mass, time, temperature, and amount. And we see there's symbols written right here. And we see that they stand for meters, kilograms, second, Kelvin, moles. And we see their abbreviations over here. Now, the one thing that we need to know about these SI base units, we can add some prefixes to them to change for the amount to see if either a smaller amount or larger amount. But we see that we're measuring here with meters is length, kilograms is mass, seconds is in time, Kelvin is the temperature, and mole is a quantity or an amount of something. Now, the prefixes that we can add to them, we can add, usually we'll deal with mega, kilo, centi, milli, and micro. And we know that a mega is going to be 1,000,000 times larger, kilo is going to be 1,000, centi is 100 times less, milli is 1,000 times less, and micro is 1,000,000 times less. Main thing here, guys, if we're going from big to small, so we're going from kilo to centi, big to small, we're always going to end up multiplying, and going from small to big, we're always going to end up dividing. Now, volume is not an SI base unit. It is a derived unit. And we see here what we have where we get unit from is just length times width times height. And what we see is we have meter time meter time meter, which give us meter cubed. Now, in chemistry, we use centimeters cubed or milliliters because basically they're interchangeable. Because this equation down here, what it does is it tells us that 1 cubic centimeter equals 1 milliliter. And that's a biggie on your test tomorrow. Make sure you know that. 1 cubic centimeter equals 1 milliliter. Now, density is the ratio of mass to volume. The equation for density is density equals mass divided by volume. The SI unit for density is kilograms over meters cubed. We normally use grams over cubic centimeters or grams per milliliter in chemistry. Those usually we're dealing with smaller amounts. Now, an example of density, what we have here is from your study guide. It says, what is the density of an object with a mass of 25 grams and a volume of 50 milliliters. So we have a mass of 25 grams, a volume of 50 milliliters. And I think on your review it's cubic centimeters, but remember they're interchangeable. So we know that density equals mass divided by volume. So we set this up and we'll have mass on top, which is 25 grams. We'll have volume on bottom, which is 50 milliliters. We go ahead and divide those guys out and we'll get 0.5, and our unit is going to be grams per milliliter. Now, moving on to looking at Fahrenheit and Kelvin, and really the only thing here is they're both temperatures, so we're just going in between them. The equations that we need to know, we know that Kelvin is going to equal degrees Celsius, and that would be plus 273.15. And we know that Celsius is going to equal Kelvin minus 273.15. Remember, Kelvin is based off of absolute zero, so you can never ever have a negative Kelvin temperature. So looking at this one, we have 298. We would plug it into, we have a Kelvin temperature, and we want to take it basically just to Celsius, not to Fahrenheit. So we would take it, plug it on in, and we would see they have degrees. We'd use this equation because we have Celsius, or we have Kelvin, and we put whatever we have in the equation. So we'd see we'd end up with Celsius equals 298 minus 273.15, and we see that we would get right around 25 degrees Celsius. If we wanted to take that to Fahrenheit, all we'd have to do is just plug that Celsius temperature into the Fahrenheit equation. Now, using significant figures, guys, if you have a problem with significant figures, you need to go back and watch the video. It's back in chapter 2 on this. Now, calculating with significant figures, when we're adding and subtracting, we always end with the least number of decimal places. And what that means, when we're looking over here, we're looking at the least precise number. And we see that, for an example, what we'd have is we see the 2 ends in the tenths place, the 5 ends in the hundredths, and the 8th ends in the thousandth. Now, the least number of decimal places, the least precise, is going to be the 1 to the 10th place. So what we do is we round everything to the 10th place, and that 9 would round that 8 up to a 9. Another example of this we see from our study guide, and what we have is we have 275.25 plus 25, and these are both centimeters. So we would end up with 275.25. We're adding that to 25 centimeters, and we're adding that up, and we get 300.25. Now, when we're looking at this, the least decimal place we know is the ones place. If we get confused on that, guys, just draw straight lines down, and what you see is this is the line that hits all three numbers. So we would just round to that place, so that 2 does not round that 0 up. So our answer would just be 300 centimeters. Now, moving on here, we're going to move on and keep on talking about significant figures and calculations. And we're looking at multiplying and dividing. And here we need to make sure that we end with the least number of significant figures. So when we're looking at a multiplication, we see in the first number, 34.6, it has 3 significant figures. Here in 12.1, we have 3 significant figures. And then lastly, in 1.2, we have 2 significant figures. So our answer must have 2 significant figures in it, and we see that it does. In another example, we see this from our review. We have 2.07 times 10 to the 7th and 4.2 times 10 to the 9th, and we have to multiply those two things together. Now, remember, when we're plugging these in the calculator, we don't put times 10. Remember, we're going to put E in the calculators that I have in class. To get the E all by itself, you would just press second comma. And basically what it would look like in the calculator, we have 2.07 E7 and times 4.2 E to the 9th. And we see that looking at significant figures, 2.07 has 3 significant figures and 4.2 has 2 significant figures. So when we multiply these guys out, we'll get an answer of 8.69 times 10 to the 16th. And we'd round that to two significant figures. So here's our first, there's our second. So that 9 does round that 6 up to a 7. So our answer would finish and be 8.7 times 10 to the 16th. Now, moving on, we'll talk about Dalton's atomic theory, and we really need to know some of the similarities and differences in this, the main things that he did. Remember that Dalton was famous just because he was the first person to produce an atomic theory and think this way. Now, he said that all mass is made of atoms, and that atoms of the same element have the same size, mass, and properties, and that atoms cannot be subdivided, created, or destroyed, and atoms of different elements combine in whole number ratios to make compounds. And lastly, in chemical reactions, atoms are combined, separated, and rearranged. Now, he was right on a lot of things, but he was off on a few. We see that first, that atoms of the same element have the same size, mass, and properties, and we see that's not true when we look at isotopes. And we also see that that atoms cannot be subdivided, created, or destroyed, and we know that they can be subdivided into protons, neutrons, and electrons. But the reason why we learned Dalton's atomic theory is because it was the first, it was original, it was the first of its time, and it was revolutionary. Now, moving on to some other discoveries, we looked at the discovery of the electron. J.J. Thomson is accredited for the discovery of the electron, and he named the particle. Now, we also look and we see that Rutherford was credited for the discovery of the nucleus. So we see that we discovered the electron and then discovered the nucleus by shooting those alpha particles. Moving on and talking about specifically the atoms and the isotopes. Now, looking at the atoms and the isotopes, we see that isotope is basically, it is a atom that has a different mass, a mass number. So it has the same number of protons, because remember, the periodic table is arranged by the number of protons. So we know that an element is an element because of the number of protons it has. So we can't change the number of protons, but the mass changes by the number of neutrons. So we see in carbon-12 we have 6 protons and we have 6 neutrons in the nucleus. But when we move to carbon-13, we see that we have 6 protons still, because it's still carbon, but we have 7 neutrons because we've increased the mass, and in carbon-14 we have obviously 6 protons because it doesn't change, and we have 8 neutrons. And we need to know that if we can add neutrons, and that just creates a different isotope. But if we add or take away electrons, we're changing an ion. But we cannot change the number of protons without changing the element. So if we can't add protons, can only have different numbers of neutrons and electrons, meaning isotopes and ions. Now, the mole. Remember, we studied the mole, and the mole, we said that 1 mole is just a quantity, and we looked at that earlier in our SI base units. But remember that 1 mole always equals 6.022 times 10 to the 23rd atoms. Okay, and we use this in our conversion factors. We always say that 1 mole equals 6.022 times 10 to the 23rd. We also remember saying that 1 mole will always equal the molar mass. And remember, the molar mass of an element is the atomic number in the periodic table. And then the molar mass of a compound is going to be the sum of all the atomic numbers in the compound.